Everyone, welcome to Gate ECE channel. Today we will be doing some questions on Laplace transform. The first question I have given in the video itself. Please pause the video to view the question, and I'll read the question now. The Laplace transform of a periodic function f of t equal to t, and for 0 less than or equal to t less than or equal to a, and after f of t plus a, which is equal to f of t. From here we know that this function is a periodic function with the period t is equal to a, because it is repeating itself after the interval a. Okay. So f of t can be written as, so the signal over one period is, for the signal over one period is f1 of t equal to f of t into u of t minus u of t minus a, right? What is u of t minus u of t minus a? It will extend up to 0 to a, right? So if it is multiplied by f of t, that means the first period, we are talking about the first period. So f1 of s, what is f1 of s? F of t is t. So t into u of t minus t into u of t minus a. Instead of, we'll rearrange the term and make it t minus a term. Okay, for that I'll add and subtract a from this, that is t plus a minus a and u of t minus a. And rearranging the term, we'll get right. And now if I take the Laplace transform, we'll get f1 of s equal to one divided by s square minus, here is a shift in the time domain, so there will be a shift, there will be a multiplication by e raised to minus as in the frequency domain, right? We have studied it when studying the properties of a Fourier Laplace transform, minus a divided by, yes, okay. So that's it. This is the Laplace transform of one period. So whenever a periodic function, please keep this in mind, whenever a periodic function is coming and if the Laplace transform of a periodic function is asked, we have to find out the Laplace transform of one period, and then the overall Laplace transform, that is our f of s, will be equal to f1 of s divided by 1 minus e raised to minus st, where t is the period of the function. Here we know that the period is a. Okay, so f of s equal to f1 of s, that is f1 of s is actually 1 by s square into 1 minus e raised to minus as minus a into e raised to minus as divided by s, the whole divided by 1 minus e raised to minus as, right? Rearranging, we will get 1 by s square minus a into e raised to minus as divided by s into 1 minus e raised to minus as. Okay. To the next question, the Laplace transform of a function f of t is given by f of s equal to ln s plus 1 divided by s plus 2. Then f of t for t greater than 0 is, we have to find out the inverse Laplace transform of this function. So this is a really good question. We can use the property of Fourier transform here. So it is given in logarithmic form, right? So instead of f of s, we can write ln s plus 1 minus ln s plus 2. So to get it in the solvable form, I am just going to differentiate both sides. Okay. So df of s divided by ds equal to 1 divided by s plus 1 minus 1 divided by s plus 2. Now let us find out the inverse Laplace transform of both the sides. That is IFT of this one and IFT of this one. We know that what happens when t into will just get the property of the Laplace transform, that is f of t having a Laplace transform f of s. Then what happens if it is multiplied by t minus t, actually minus t, we'll get d by ds of f of s, right? So if we take the inverse Laplace transform, we'll get minus t into f of t. This will become minus t into f of t. That is the inverse Laplace transform of a d by ds of f of s, equal to IFT of s1 divided by s plus 1 is e raised to minus t, and 1 divided by s plus 2 is IFT is, actually it is not IFT, ILT. Okay, I apologize. ILT, inverse Laplace transform. Okay, so e raised to minus 2t and f of t equal to e raised to minus t minus e raised to minus 2t divided by minus t, which is rearranging, we will get e raised to minus 2t minus e raised to minus t divided by t. Okay, now let's do the next question. Here in this question, x of s equal to integral s to infinity 1 divided by s square plus 1 ds. And we have to find out x of t. Okay, so here also we are going to use the property of a Laplace transform. So f of t having a Laplace transform f of s. What is 1 by t into f of t's Laplace transform? Equal to integral s to infinity f of s ds. Okay, so it is already given in the question in the integral form. So we'll have to find out the inverse Laplace transform, that is our x of t is to be found out here. Let us find out. That is the inverse Laplace transform of x of s equal to inverse Laplace transform of integral over s to infinity 1 divided by s square plus 1 into ds. Okay, so this is the Laplace transform. We'll get 1 by t into f of t. Okay, so f of t's Laplace transform is this particular thing, that is 1 by s square plus 1. So to find out f of t, we have to find out the inverse Laplace transform of f of s, that is equal to what is a divided by s square plus a square, that is sine t we are talking about. Our a is equal to 1. So the inverse Laplace transform is sine t divided by t. So that is the answer. Thank you. Let's move on to the next question. The 28th question. The Laplace transform of the sinusoidal pulse x of t shown in the figure A is x of s. Then x of s is. So I'll just draw the signal here. That is our x of t is given here, right? Laplace transform of the signal x of t shown in figure A is x of s. Okay. Then x of s is. We have to find out the Laplace transform of this particular figure. Okay. So this is actually a sine function, right? A sine function start from 0, then gets back to the x-axis when it is pi, and actually there is another one too, that is in the opposite phase, but here that is not given here. That means it is stopping after pi. That means our sine t is actually its duration is 0 to pi. That is u of t minus u of t minus pi. What if sin t is multiplied by u of t minus u of t minus pi? It will only be there within 0 to pi. So I can write it like this. Okay, this function can be written as sin t is equal to sin t into u of t minus u of t minus pi. Right. So our x of t equal to sin t u of t minus sin t u of t minus pi. So here it is t minus pi. So here it should be t minus pi unless otherwise we can't find out the inverse Laplace transform. So what is sin t minus pi? Sin t minus pi is minus sin t. So instead of minus sin t, I am going to write sin t minus pi. So x of t will become sin t u of t plus, instead of minus sin t, I am going to write sin t minus pi u of t minus pi. Now we have t minus pi. We can simply find out the Laplace transform. Now x of s. What is the Laplace transform of sin t? It is a divided by 1 x square plus a square. That is 1 divided by s square plus 1. And the other one is actually it is shifted in the time domain, right? So we'll have to multiply it with the e raised to minus pi s. That's all. Divided by s square plus 1. So the whole answer is 1 plus e raised to minus pi s divided by s square plus 1. That's all. So that's the answer. Now let's move on to the next question. Actually, it is a periodic function, right? I'll draw the function x of t over here. And so on. It is a periodic function with a period 2 pi. It is repeating itself after, actually it is, 2 pi, 4 pi, 5 pi and 6 pi. So this is a sine function, but it is extending between 0 to pi only, and it is shifted to the left side by pi. So we will have to use some properties of a Laplace transform over here. That's all. Actually, we are going to assume another function that will be much more easier. That is, I am just going to take a function x of t similar to this but only shifted to the right side. Okay. At last, we will consider the y of t. Okay. This is 0 to pi. Again, this is 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi and so on. This is our x of t. Okay. And I am just going to find out the Laplace transform of x of t. Okay. We know that the Laplace transform of a periodic function is equal to the Laplace transform of 1 period divided by 1 minus e raised to minus pi, s t, where t is the period of the function. Okay, so the Laplace transform of 1 period, that is 0 to 2 pi. Okay, 0 to 2 pi is x of t. I am just taking 1 period. Okay, 0 to 2 pi. Just taking, this is x1 of t. So x1 of t equal to 2 sin t, its amplitude is 2, okay. 2 sin t u of t minus u of t minus pi, because it is only duration is 0 to pi only. So x1 of s, what will be x1 of s? Will be equal to 2 into 1 plus e raised to minus pi s divided by, we have found it out earlier, only difference is there will be a magnitude difference of 2. So I'm not going to do that step. In the previous question itself, we have done the same. So that is it, and x of s, that is the overall for a that is Laplace transform is x1 of s divided by 1 minus e raised to minus s t. That is 2 into 1 plus e raised to minus pi s divided by s square plus 1 whole divided by 1 minus e raised to s into t. What is t? 2 pi, right? So the answer will be equal to x of s. This is x of s is equal to 1 divided by 1 minus e raised to minus 2 pi s into 2 into 1 plus e raised to minus pi s whole divided by 1 plus s square. Okay. Now, this is for x of t. So, what is the relationship between y of t and x of t? I'll just write it here. So, y of t is actually the shifted version of x of t. Or in other words, I can write x of t when shifted to the right side, so left side by pi, we'll get y of t, right? So, x of t minus pi, that is the difference. So, x of s is equal to x of t minus, x of s we have found it out. And what will be x of t minus pi? The Laplace transform of x of t minus pi will be just be multiplied by e raised to minus pi s into x of s, right? So, y of s will be equal to this particular thing into x of s. So, I'll write it here. Y of s equal to 2 into e raised to minus pi s divided by 1 minus e raised to minus 2 pi s into 1 plus e raised to minus pi s divided by 1 plus s square. Okay. So, instead of, we are going to simplify it, okay. So, instead of e raised to minus 2 pi s, I am going to write e raised to minus pi s into e raised to minus pi s. No worries, okay. 1 plus e raised to minus pi s, 1 plus s square. So, if I am taking e raised to minus pi s outside, we will get from the denominator, okay. E raised to minus pi s I am taking outside, I will get e raised to pi s minus e raised to minus pi s into 1 plus e raised to minus pi s divided by 1 plus s square. So, pi s and pi s cancel out. We will get 1 divided by e raised to pi s minus e raised to minus pi s whole divided by 2. This 2 is coming downwards. Okay. 1 plus e raised to minus pi s divided by 1 plus s square. So, what is it? Sin x equal to e raised to x minus e raised to minus x divided by 2, right? So, instead of this, I am going to write sin h pi s, okay. So, I will get 1 plus e raised to minus pi s divided by 1 plus s square into sin h pi s, okay. That's the answer. Finished. Okay, with that, I am going to end this video on a Laplace transform. Please visit my Instagram page as well as my Facebook page, where I will be sharing lots of problems and practice questions daily, and also short notes I am sharing there. Please have a visit into that